Everyone, welcome to lecture number 8 of Applied IoT. Hope everyone is doing well. Last time we stopped at value chains, so we took an introduction to value chains. But in lecture number 7, we little bit went off topic and we looked at what are the practical applications of IoT. So the main reason that I did that lecture, that what I wanted to convey to you is mainly through that lecture, is that the different applications that are there for applied IoT. So, or different applications in different domains, how the sensors are being used, how the technology is being used, how parts of mechanical engineering or parts of mechatronics, electronics come together in IoT. How these things are applied, what are the solutions out there, how the sensors are being used, how the actuators are being used, how the IoT environment is being used, how the cloud is being used to support IoT, so on and so on. So in different domains, in different industries, for different automation solutions, we can use IoT and how to apply them, right? So in this lesson, or in this set of lectures in applied IoT, we are mostly concentrating on the application of IoT for automation, for resolving problems or issues, for making processes more productive, if stopping human error, collecting of large amount of data, creating new opportunities, so on and so forth. We are learning the application of this IoT industry to in what are the services that can be provided, what are the products that or manufacturing side we can do, right? How to create value chains, mostly towards application and business aspect of it, right? So to do that, we have to understand what is IoT in the real world, how IoT works in the real world. So that lecture was mainly tailor made for that. I encourage each and every one of you, if you are to build the innovative idea, if you are to apply IoT solution, first of all you must understand what is IoT and how IoT is applied for different situations around the world in different domains. After understanding what are the existing products, what first you can understand what are the existing products in different domains, what they do, what are the processes they do, what are the problems they solve. Through that you can then apply those products for those existing solutions or automation solutions, processes of automation through IoT to situations you face as an engineer. And then you may also, then after that the next step would be creating new innovative solutions, creating new ideas, engineering new solutions, IoT devices, um, to be applied in different domains. So to do all that, first you have to understand it. So that lecture was mainly there to talk about how these IoT solutions are applied, what are the IoT solutions available. uh, it's only a small amount which we checked, right? Because I was just going through different domains to show you different things. There's a lot of examples in different domains, so it is, if you are interested in that a particular area, you can go through the content and try to see what are the products and solutions out there. So we stopped at value chains, right? Before before going into value chains, right, we first talked about IoT devices, right? We talked about Internet of Things describes the network of physical objects or things that are embedded sensors, actuators, processing ability, software, and other technologies for the purpose of connecting and exchanging data with other devices and systems over the internet. So that is the general definition of IoT, right? Then we talked about different examples of IoT devices, from cameras to temperature sensors, lights, robotic arms, hospitals, so on and so forth. Then we looked at applications of them. In the last lecture, we looked at videos how these things, or IoT devices, are being applied, right? We then talked about applied IoT. Applied IoT refers to the practical application of Internet of Things technologies and solutions in real world scenarios across various industries and domains. It involves using IoT devices, connectivity, and data analytics and cloud platforms to solve specific challenges, improve process, enhance decision making, and create value. So that is the main definition of, or introductory definition of, applied IoT. One of the main things that you have to understand from the IoT lectures we have and applied IoT is, applied IoT is more towards theory and how IoT can be applied. What are the solutions out there? What are the how to look at a problem and resolve it using IoT? What are the businesses, or what are the opportunities out there for IoT, right? When we are talking about value chain, we have to talk about those things as well. We talked about characteristics, right? There are uh, connectivity, of course. There's a network if you are connected to the Internet of Things, right? Sensing, perception, or the hardware section, data analytics, automation, and control, scalability, security, real-time communication, heterogeneity, edge computing. We talked about all of these. Then we talked about machine to machine, right? What are How IoT can be used in machine to machine, and how the lines have been blurred in machine to machine itself. I think one of the main best examples in the last lecture, in lecture number 7, if you haven't checked it, or if you don't remember, I recommend you to go back and check the first 2 or 3 videos, where we can see that machine to machine in an IoT fusion, or use of IoT to help in machine to machine in scenarios. For example, so if you have legacy systems and legacy machines, right, to do predictive maintenance, how IoT is being used, right? IoT is there to check vibrations of machines, right? Then to see the vibrations, heat, use of electricity, so on and so forth. So that is a good example of machine to machine in an IoT being fused together. So, for example, the machines could be working by themselves according to protocol, but if to check that the machine's health is good, we can attach or ad hoc devices which are IoT devices to measure them, right? So that before breaking the expensive machine down, by using a simple IoT device, we can predict if there are any problems and maintain them without any issue. Smart cities, right? We talked about them extensively. It's a cluster of other IoT systems like smart grids, transportation, healthcare, in one place, where in a city itself, right? It's a bunch of systems working together. Um, we talked about machine to machine and Internet of Things. What are the differences? Scope, data connectivity, scalability, data analytics, so on and so on. We talked about operational technology, or OT, which is also now a term which is being used in industries, similar to IoT service providing. OT service providing is a part of industries today. Then there is also a term called IoT, where industrial Internet of Things are also there. So all these terms are used for applications of IoT in industrial scale level. I think you have seen the drone footage where DJI have given solutions to monitor electricity lines, create smart grids, and so on and so forth. I think you have seen those videos in the last lecture itself and see applications. So by now you will be able to look at IoT solutions or products and understand the application of it. And when you see a problem in a legacy system or existing system or a manually done work, now I think you will be able to give a solution for a problem or increase like the process, the productivity of the process, right? We talked yeah, through IoT you will improve the process or enhance decision making through IoT. And in I think you will be able to now think of a IoT solution for that. Right, so from that we move to a marketing perspective of IoT. We talked about market size, we talked about industry adoption, connectivity, and devices, data. We talked about different systems that can be there, right? All these things, these are different. Let's say, if you take the entire IoT market, more there are set of domains which IoT works in, either agriculture, weather, smart homes, smart cities, is electricity grid, so on and so forth. So there are IoT solutions for most of them. Security, privacy standards, startup, and we talked about these topics as well. Regulatory environment, and we talked about how uh, IoT is part of these when going into the future, right? What technologies would dominate? It would be mainly artificial intelligence, renewable energy, virtual or augmented reality, blockchain technology among the so these are technologies that can be seen going into the future, which will be applied all over in different domains. And to that list, Internet of Things or IoT is a main topic in the list of things that we will see going into the future in the world of technology. So we know the overall market perspective for IoT is very positive. Then we talked about value chain. So value chain is a series of consecutive steps that go into the creation of a finished product, from its initial design to its arrival at the customer's door. The chain identifies each step in the process at which value is added, including the sourcing, manufacturing, and marketing stages of its production. So, this is a general overview or a general chart of value chains, right? A company, if you are running a company, all these things, right? The manufacturer, the human resource, the technology, the procurement, and inbound logistics or the raw materials of operations which we do to process that material, right? Then to create a product, then outbound, or we have add value to the raw material, then we give the outbound logistics, marketing, and after sales, which gives out a entire product. And the value of that product is totally sort of is made out of these all these um, all these components, right? You have to the value, like if you don't take the net value of the or the extra bit you charge, or the net profit of the product, the rest of the value is actually spent on these processes. So these value chains ends help to function a big factory, a manufacturing facility, or even a service providing company, where the end product would give value to this company. The value of the end product is determined through this process. So what we have to actually look at it is, right, this value chain can be applied for any company, right? This value chain is applied for any company, whether it's a service providing company or whether it's a manufacturing company. So end of the day, the service which has been provided or the actual object which is being created or made is the product. So when coming into machine to machine value chain or IoT value chains, that I think we have to concentrate more on, right? There are different layers that are there, where different businesses can emerge or different companies can emerge, right? So when talking about the entirety of value chain, right, we can go step by step and understand, right? if we have a if we have For example, if we have a company which provides connectivity, so we can talk about company overhead and management, including in financing and planning, right? These things are and human resource and technology development. These things are these three are commonly we can take. Then there's the procurement, right? Procurement So from procurement, inbound logistics, operations, and outbound logistics, for those things, right, each there are different companies is for giving connectivity for devices, service enablers, and platforms. So we will talk about them, how this general value chain will be applied for each and every position. So one of the things that you have to understand is, right, you can create a value chain for for sensors itself. To develop sensors, to manufacture sensors, you can have a value chain, and also you can have an entire value chain for IoT as a service. If you are providing a IoT service, or if you are providing IoT solution or a IoT application, you can provide from the device, connectivity service and mobile platforms, IoT applications, and till management service to the customer. So you have to understand each when we are talking about M2M value chains, or if you are talking about IoT value chains, OT value chains, IIoT value chains, whatever, right? Each value chain step can be performed to add value to your company, and anything, or you can just concentrate on one particular, like network connectivity. A company could just concentrate on one single um, chain of this value chain, and internally in that company would have a value chain of itself to give the end product of a network connectivity, right? So it's a in that sort of way, there are different types of ways that we can define the value chain. But okay, let's start from M to M value chain. Machine to machine value chain. So in this we have four main components. So machine to machine or M to M is basically where a concept. This is a concept as we talked about before, IoT, and these are mainly in manufacturing industry, and mainly in heavy industries, right, where machines have to communicate or exchange data with other machines to work. So in this we have four components. In main thing we are covering this M2M IoT, M2M or IIoT or OT, these terms, right? These terms are all part of IoT. In a sense, it's a it's all part of IoT. Therefore, we will concentrate more on IoT value chain for now. As per the syllabus, we will also look at M2M value chain, right? So the value chain is divided in, we can categorize four main parts: embedded mobile devices, or in a shorter sense, devices, hardware materials, or basically machines, right? Network connectivity, which is if machine to machine is talking, in between them there should be a network running, right? Service enablement services. So for this service enablement services means uh, a platform, end user platform, where humans can interact with machines and to get look at information and data which has been produced from machines. Value added services mainly maintenance, cloud services, so on and so forth. So if you talk about the first one, of course, so this whole chain itself could be inside a company, right? If you go to this value chain diagram, which is a general concept of it, for the set of primary activities, this whole value chain could be there, right? If the company itself is managing the M2M entire process, from the devices to networking to software which is needed to do the network communication, as well as to drive the machines, then end user programming and those applications and monitoring tools and everything. Or each company can get these services from other companies, so we say B2B. If you are a company which is engaged in mining activities, your main goal in a processing plant, your main goal wouldn't be to maintain the machines or to manufacture the machines or to manufacture the interfaces, create the network. Those are not your main goals. If you are mining, your main goal is to produce raw material by processing the dirt you dig out from your mine. So in that case, that particular mining company can get services from other companies which their main process is to either build devices or to maintain network or create network, have applications that can manage networks, or value added services who can maybe carry out maintenance, right? I think one of the terms that may, when coming, okay, before going into value added, we will start with embedded mobile devices. So basically, embedded devices. So these could be from printing machines, steel manufacturing, in car manufacturing. You can take even robotic arms for these things, mining. Basically, when mining for raw materials, you would need huge machines. Production of electricity, production. Uh, so we are talking about giant turbines, production, aeroplane manufacturing, so on and so forth. There will be tons of manufacturing and heavy duty work when coming into heavy industries. Shipbuilding is one of it, so on and so forth. There will be a lot. And in those particular, if you take a shipbuilding yard, there will be cranes lifting up huge portions or parts of ships and welding them together, and these cranes have to communicate between the ground and their positioning, right? Or these cranes have to, there will be multiple cranes which have to be communicating between each other, so they should be networked. And now you can see how these facilities are being, or how these value chains are being constructed. So one of the main points that you have to understand in this is that okay, so a company that is building hardware can get necessary or can communicate or can transact with, so their value chain is let's say it's building hardware devices, so their value chain is mainly concentrated on building the machine itself. The end product would be the machine, right? Then for networking, they can connect with a service provider, ISP, or any other service provider uh, who's more facilitating in networking. Etisalat, Airtel, Dialog, Mobitel, if it's in Sri Lanka, or otherwise um, in other countries, 3M or um, T Systems, BT, British Telecom, so on and so forth. You can give those contracts to each and every ISP to maintain the network in the construction yard, in the mining fields, in right, in any heavy duty industrial place. For maintaining the network you can give, and for that each service provider, each ISP has its own value chain, where their main goal is to maintain the network connectivity, maintain the network health, right? And by uh, by then it will be, they will be enabling machines to speak with other machines. uh, so in network communication, there will be network protocols, softwares involved, and hardware components involved, switches, core devices, so on and so forth. So these things again will be split into different parts. Let's say for example, uh, the value chain of Dialog would be, Dialog or Mobitel would contain, they will take raw materials as Cisco core switches, or Cisco as access points. The hard, so inbound logistics would be them. For Cisco, the value of the product will be their outbound logistics would be the core switches. So that is value chain inside another value chain. So you can understand what I'm trying to say here. So what we are basically talking about in this chapter, or in this portion, is that uh, inside a IoT system, or inside a M2M system, inside OT system, inside IIoT system, whatever the term which is being used, each and every component, each and every component of the value chain has the ability to create value. There's a business opportunity there. There's the ability to create value. You can have a network connectivity company right? You can build a network connectivity company which will provide the network facilities as a service in this value chain. You can be a heavy duty machinery product producer who will be providing the hardware, or you will be the hardware manufacturer who will be providing the hardware, so you will be at this place of the value chain. Or you will be a developer who will develop the platform applications, data management, security, and those things. um, uh, so back end and front end of the application, where uh, um, where they can continue to monitor the functionality of the hardware devices. Then value added services. Value added services would be end user services, infrastructure, uh, regulatory bodies, auditing. Then you will have, of course, maintaining these hardware devices, maintaining the network, maintaining the application, so maintaining back end and front end of it, so maintaining everything. So there will be more value added services created from that, right? So you can see that for each and every component there are set of companies which are there. So what I'm going to do is, right, we can now we have an idea on, right, each of these value added components are inside these, and those components will have different value chains, so on and so forth. So if you take the global economy itself, value chains, it's a very complicated, it would be a very complicated it would be very complicated in nature. So we are just going to concentrate on IoT side. So from M to M we can move to IoT value chains. So let's concentrate more on this, right? I have selected this picture because this picture gives what are the components, a breakdown of each value chain component. So each value chain component, similar to M2M, because our main goal is applied IoT, we are going to break down each value chain component and see what are the components inside. So after looking at that, right, after looking at the value chain, so we can then talk about the companies which are actually involved in IoT value chains, right? So this is our plan or the path of education that we are going to take, learning about IoT value chains. So so continuing in IoT value chains, the main one, the first one, right, we talked about different layers. So the first layer would be the perception layer. The perception layer, or the devices or the hardware itself. The hardware layer or the physical layer or the perception layer. So in a value chain, in a IoT value chain, this would be the first thing we will meet, the devices. We the physical devices. Input and output is both taken through devices itself. So number one, we talked about this a lot, so we can go through quickly. Sensors, then actuators, embedded systems. Embedded chips means embedded systems include chips that process these things. So these are hardware components. So there are manufacturers of sensors, actuators, and embedded systems. So or embedded chips. Who are these people? Mainly, what are the two companies we talked about Raspberry Pi, we talked about Arduino. Then there are SIM cards. SIM cards are mainly for mobile communication, this we know. Why we need mobile communication? If you look at the previous lecture, lecture number 7, right, we veered off from what we are learning to understand what are the IoT applications in the modern world right now. and how IoT is applied. In that, you will understand for some functions, the network, we would need to take network connectivity from network service providers, through mobile network service providers, because connectivity such as Wi-Fi or Zigbee or those connections will be not enough. So in that particular case, to maintain the services themselves, SIM cards are needed. So then we would have system design, of course embedded system, firmware drivers, yes, same for creating embedded systems, radio modules, hardware components for communication, components, SDKs. Okay, so for all these things, there will be sales, marketing, and distribution. So you can see that this device itself has its own value chain. So we know that there are number of numerous vendors or numerous sellers of devices in IoT value chain. So if you are interested in joining the IoT value chain, right, you can create sensors, you can create actuators, you can create embedded systems, but that is the all these components are deep part of IoT. So let's start from the shallow part of it. Why are we first trying to develop a sensor itself, which would need lot of R&D? If you are a startup, you won't be starting from a sensor itself. If you are going for IoT, you will be going through an embedded IoT device, right? You will be connecting the sensors and the actuator with the embedded system, which would have the embedded chip, the radio module, firmware drivers, and so on and so forth. You will be collecting them all together using a 3D printer. You can print in a cover for it, and you will be making an IoT device, right? We went through many examples of IoT devices. So by connecting all these, so in the IoT value chain, if you have devices as a value adding component, the very first company would be the company which will be creating IoT devices. So their inbound logistics would be sensors, actuated, embedded chips, and these things. Connecting together, programming them, right? Putting a nice cover on top of it, and putting it to the market itself would be their product. The IoT, so we talked about smart watches, we talked about smart alarms, smart lights, smart security systems, right? Contact sensors, proximity sensors, so on and so forth. So all these devices, right, would be all these devices would be end product of a value chain of a company which would create IoT products. If we are to dive deeper, a company that can have the manufacturing capacity to create sensors, create actuators from scratch, right? If you have a screen, to build a screen from scratch, right, they will have their own value chains where their end product would be a sensor or actuator or a embedded system, right? Why did I say creating a device is easier or the shallow end, and creating a sensor or actuator is a deep end? Let me give an example before going into the next chain link of the value chain, right? So if you think about companies like Sony, Samsung, right? Or let's only take Sony itself. Sony is a very large company which have a big budget for their R&D, and they have a set of their own products. They have their patents and everything. So they are very famous for their cameras, and their cameras mainly rely on their camera sensors, right? Their image sensors. Now, as an IoT device, we talked about image sensors. Um, so, in if we are to build a IoT device with a good camera which can take images or videos, right? As a IoT startup, what would be easier, to get the image sensor from Sony, or to build your own image sensor? Because our end product is going to be a IoT device, right? It's 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 not, the thought is not discouraging. We are just trying, to build from ground up. In that case, the easiest way is to build a IoT device using sensors and actuators which have been developed through other companies. Even in the smartphone industry, if you take, even from Apple, if you take even other large brands out there, right, they will use image sensors from Sony. Some companies use screens from Samsung, right? So the the first the first component of a smartphone manufacturer, right, the first, they will be, their value chain end product would be, right, their outbound logistic would be a smartphone, their inbound logistic would be a screen, image sensors, speakers, microphones, so on and so forth, which is needed to build a phone itself. They may come from inside the company or outside the company. If you are a startup, it is easier, logical, and um, commercially viable to bring those components from outside. So here you can be in the value chain, you can be a company which provides these hardware components itself, or a company which combines all these hardware components to give a IoT device itself, right? So the opportunities are endless, right, in the hardware industry itself. um, Hardware is something that is been, in Sri Lanka as a marketplace. Hardware is a Hardware has a lot of opportunity, and hardware is an open space, because there are not much there are not a lot of companies that step into that space. If you take the main companies working in Sri Lanka, there are mostly towards software application support, IT support, like IT infrastructure support, connectivity, networking, and those sides. Hardware side itself, building IoT devices and so on and so forth, giving IoT devices as a solution, there are very less companies out there. So let's go into the next topic, connectivity. So the next link of the value chain would be connectivity. In connectivity, we will find service provider, local, international protocols, and we will have 2G, 4G. Right now, we can forget about 2, 3. Now it's mostly 4G, and we are transitioning into 5G technologies, right? So here the local service providers, if we are talking about local service providers, the local and international, we have two topics, because some of the companies are uh, multinational. So multinational companies would need large scale network connectivity, right? So depending on the size of the company, the service provider changes. Protocols, of course, mostly go through the same for, if you are communicating through the internet itself, or if you have internal communications for IoT systems like Zigbee or Z-Wave or things like that, and we can use those protocols as well. LPWA access gateways, satellite wired network service device provisioning. So uh, if you take all these if you take all these subjects, basically if you go to the very first, service provider, right? The service provider is the one who gives the network connectivity, either the network connectivity we want as a company, or the network connectivity which is being given as a system, as a part of the IoT system. End of the day, any service provider, if you take generally, if you take Mobitel or Dialog, local service providers, right? They will provide the protocols, they will provide 4G 5G access if needed, LPWA access, gateways, satellite connectivity. Of course, they can provide as a third party service, or there are services like Starlink available today, wired and everything will be uh, network service, the service of the network itself, maintaining that network, maintaining the hardware components, and device provisioning. So again, the hardware components, fixing, buying them, fixing them, connecting them, maintaining them, cleaning them, replacing them when there are errors, uh, keeping the health of the network itself up, keeping the connections ongoing. So there's a service providing element to that connectivity part as well. There's a hardware component to it as well. There's a software component to it as well. There's administration, access control and everything part to it as well. So connectivity in whole can be another part of the value chain. So sometimes companies like Dialog, companies like Mobitel can provide, if they are looking to expand their business, they can use the existing infrastructure that they have. They can use the existing uh, cellular infrastructure, as well as fiber optical or other cabling infrastructure that they have, to give IoT products to the market. So that is also an advantage. So we are basically uh, going going back the value chain, right? Yeah, so companies that provides connectivity have the ability to introduce devices which can use that connectivity to the market as well. Generally, the hardware device providers and the connectivities are two separate components when coming into it. But when coming into Zigbee or Z-Wave or things like that, or if we look at the internal network of a company, or internal intranet, or if you can say the LAN connection, like local area connection, can be provided by the IoT service provider, sorry, IoT device provider itself. But when coming into WAN connectivity, connecting to the internet itself, you would need a ISP for doing that, or internet service provider. So that connectivity component is also a value adding component. Next component would be the service enabler platform. So this means IoT platforms, security, data storage, data management, data transmission, rules engine, device management, device provisioning, integration, API, SDK, app enablement. So looking at these topics, what is the first thing that comes into your mind? Cloud services. Most of the time, this could be a part of cloud services or server management. Data storage, data management, transformation, rule engines, device management. This comes under part of services. Security would be also part of either a data center, right, either on premises or in the cloud itself, right? So all these would come as a cloud service. Now here companies are there for providing cloud services and providing specific IoT related cloud services as well. If you take Azure, if you take Google, AWS, anything, you will find dedicated platforms to have IoT specific services. On top of that, device manufacturers such as Arduino also provides cloud platforms for IoT, right? So then again, when a business expands, right? When a business expands, your value chain can be divided into certain categories, right? You can start with devices, you can provide security or your IoT platform, the storage of data and everything as a cloud service as well as the next step. Or there are separate cloud services that you can use for these services. So again, for example, the inside this chain link you will find IoT platform developers or development companies, which would mostly be in collaboration with the or be a part of the hardware device provider. Security part of it will be mostly provided by the cloud service itself, or there will be standards involved. That means security, the administration part of it, the management part of it, the settings, the changes needed, and the protocols which is needed to be carried out should be there. So there is a service element to it, or administration input. Data storage, data management, also again there's a management element. So a company can provide these things as a service and use cloud services as a foundation, right? So if you take for those companies in the value chain itself, inbound logistic or the procurement would be with either with Google Cloud or AWS or Azure. So that would be, so the cloud service will be the inbound logistics. Outbound logistics would be the services of maintaining data storage, transformation, rules engine, security, IoT, running the IoT platforms, APIs, SDKs, and all these things, running them and doing all the back-end work basically would be the service or the end product of them. Other point would be if it is a on-premises server, then the inbound logistics would be OS for the on-premises server, hardware, equipment, electricity in gigabit, like high fast internet connections, so on and so forth. Operations will be putting them together and creating a server, then installing your applications, having databases, so on and so on, maintaining them, having security protocols and so on and so forth. So maintaining the whole on-premises data, on-premises structure would be the product of that particular company. So services as a product. So similar to similar to connectivity, there will be different value chains working together to build this IoT value chain part of it. If you take connectivity, 4G 5G antennas, they will be not be provided by Dialog themselves. They will procure those from either Huawei, Ericsson, or some company which produce those antennas. So as you can see, inside the value chain itself, there are numerous amounts of links linking chain links linking each other together to produce value, right? This is what a value chain is in the modern day. It's a very complex structure. But if somebody asks, describe the value chain of IoT, this is the basic value chain structure. And in that value chain structure, right, you will in that value chain structure, under devices you will find these components, right? Under connectivity, companies provide these components, right? Under service enablement, these components, and each of those companies have their value chains, and those companies take their inbound logistics or procurement from other companies which would have similar value chains, right? Then IoT application. So this is we are service enablement platform is mostly the backend development part of the application. IoT application means the front end development part. Dashboards, alarms, notifications, application development, UI, UX design, CI, CD, DevOps, vertical solutions, building of services, system integration, API development. So as you can see from all these topics, right, as you are IT students, I think these two components, service enablement platforms and IoT application, are basically what we are talking about is front-end service providers and back-end service providers. So if you take IT infrastructure, right, this becomes a part of IT infrastructure. If you remember, when we were finishing in when we were introducing machine to machine, about machine to machine, right, we then talked about a concept called OT infrastructure. Like IT infrastructure, there will be OT infrastructure which would be the same. It is so in a OT infrastructure there will be network, there will be databases, there will be applications for humans to interact with, but there will be a hardware component to it. Like the end product, inputs and outputs will be coming from the hardware. So basically IoT, right? In this IoT, the devices, right, if you take IT management, right, if you are an application company, you take care of the application itself. But if you are into ITSM, internet service management itself, you have to manage the laptops, you have to manage the data center components, you have to manage the network core switches, and so on and so forth. You have to manage those hardware components as well, right? Adding IoT to it means adding more hardware components on top of laptops, desktops, data center infrastructure, and so on and so forth. So basically in this value chain we are addressing the same thing. Managed services, user management, onboarding, licensing, application management, cloud hosting, server management, remote monitoring, billing, CRM, customer care, blah blah blah. All these, right, if you say customer care, tech support, so all these part is service management. What is the service? What is the service component of it? The service component is managing the hardware devices, managing the network, managing and servicing the hardware, managing servicing the connectivity, managing servicing the back end, managing and servicing the front end, right? In managed services, that is the main part they concentrate on. In service enablement platform, we concentrate on construction of the backend uh, uh, foundation, or the construction of the backend, including starting from either cloud services or on-prem data centers, then storage uh, to build in the backend of the application. IoT application includes dashboard, alarms, application. You can see now, we talked about how the data is taken in through hardware components, where we normally say sensors, through sensors, and those data should be displayed to the human who is controlling the system, and the human should understand those data. So that data should be processed in the backend and stored to compare them or to recall them, and so on and so forth. Service enablement platform does that. In IoT application, the dashboard, the alarm notifications, the applications, right? Those things gives the information to the user, to the person who is actually want to know the status of the IoT system itself. So developing that would be developing the front end part of so front end development. This is back end development. This is networking. This is hardware development. um, managed services managed services is managing the hardware, the network, the back end, and the front end. Basically, infrastructure management. In IT, we call it IT infrastructure management, right? There are plenty of companies around the world, right? If you take companies like Accenture, if you take companies like WSO2, um, companies like that, right? Even if you take uh, companies like Dialog, Mobitel, they also manage services because they maintain the network line. Accenture and those companies, they do IT infrastructure. Dell, HP, Lenovo, companies like that do devices. This is in IT infrastructure. But when you go to OT, or operational technology, or IoT value chain, so uh, in a IoT value chain, you will be changing mainly your devices from laptops to devices with sensors and actuators. Network mostly would be the same, but there will be specific networks dedicated to IoT systems, including Zigbee and Z-Wave, Sigfox, things like LoRaWAN, things like that. Service enablement platforms and IoT would be e- pretty much similar to use of applications, right? So application development, it would be the same thing, because end of the day, right, when we talked about IoT products, right, if you can see the image which is being produced by your IoT device in your smartphone, that means there is a whole back end and front end development taking place to develop the app, right, to store the information you need, and so on and so forth. So that part of it is purely on going through a development life cycle. Managing all these services, then you have the customer. Customer could be a B2B buyer or B2C buyer or user. B2B means business to business. right? Business to business means, let's say you are in the business of providing devices. You have a set of IoT devices. Let's say you have a smart fire alarm with you. Business to business, let's say the Petroleum Corporation of Sri Lanka wants to buy your smart alarm system to detect any fires quickly and respond, right? You will, let's say on this, on this you will provide a device, right? And you will provide the application with that device, right? uh, so your business will be providing a IoT device with the necessary applications to interact with that IoT device to, that is your business, right? Your smart smart fire detection system or the IoT device is the is your product from your business, will be given to another business which is on distribution of energy or distribution of oil, petroleum. For them, they are using it for safety purposes, but here the interaction is between business to a business. Business to a customer. You have a smart, let's say you have a smart alarm system, or you have a smart camera system which is used for security. You have a application with you which is built so that a person can check these security systems through your phone, or if uh, somebody or unauthorized persons try to move into that area, right? Your smart cameras will detect the motion, right, and send an alarm to the customer's phone, right? So that means you are giving a um, device and an application. Of course, the connectivity to the internet will be either you will be depending on the customer's usage of the network connectivity, right? And this system is for homes, right? You go there, you fix it, you uh, and you establish the cameras around and cover everything up, right? And this is an individual person, this is a customer. So B to C, business to the customer. Another difference is, if you take B to B, right? The best way to think about it, right? If you are selling a product from B to B, you are being part of this value chain. For the let's say the petroleum example, your business product is becoming a part of the infrastructure of that company, right? Physical infrastructure, or here it says, you can say technology development part, or uh, you will be basically a part of that value chain of another. Your product will be a part of the value chain of another company, or your end product which would have value, right? End product of your value chain would be a part, either it would be infrastructure, either it would be inbound logistics or procurement of another company, which would end up being which would end up being part of the value that it is being created, right? Here in this case it's petrol, when the company buys smart smoke alarms from your company, the Sri Lanka Petroleum Corporation, they have to Ceylon Petroleum Corporation, so CPETCO have to uh, you know pay the bills for your company. If they want to do that, they have to uh, get value out of their product. Their product is distribution of oil, and from petrol they have to get some money to cover that infrastructure, smoke alarm infrastructure. So you can see how it goes. But if it is a customer, that would be it will not be joining into another value chain. It would be the end product itself. In the CPETRO example, the end product would be petroleum, right? And we will be part of the value chain of the petroleum, being the infrastructure or user, right? If you are a company if you are IoT company which use IoT, then you are a user itself. It's like a Mobitel employee using a Mobitel SIM to do work. Uh, so so now I think you have a understanding of this value chain, right? Along the value chain, value is added. This value chain creates an entire IoT system, right? This value chain creates this entire creates when creating an IoT system. All these chain links needed to be fulfilled. There should be devices, there should be connectivity, there should be service enablement enabler platforms, cloud or other data centers, IoT applications or front end applications. There should be service management. So all these things, from hardware to network to back end to front end, should be maintained, and the end of that should end of the day should be sold to a customer. This is the value chain. This value chain could be built by one company, or as given as one product, or given as it could be business to business, it could be a business to customer, or just user itself, right? You can see, okay, if you have, this is a general understanding of the value chain, right? And this is the normal value chain that I use this picture mainly because this breaks down the components of each value chain, right? If you have, right, if that is why I want to say, like, okay, if you have application development, right, the developers would be maybe using let's say, okay, we are a IoT company, we need to have a application for our IoT device, so the human being could interact with that hardware component, or the user can interact with that hardware component. Okay, but we are IoT company, we are a hardware company, we need to build this software. So we will talk to a software company. Okay, we have this IoT product, we are going to make this IoT product, can you make a application for this? The application company says, okay, I will make the application and everything, but we need a place to host this application. So the application company then talks, buys another product which is from a cloud platform, right? So you can see that along this value chain there are other value chains joining in, either partially or fully, right? So sometimes this device we will sell it in the market to the customer saying, hey, we have we have this device, you can download the app and you can use it. But behind the scenes, there one company will be designing and developing the hardware component, one company will be designing and developing the software component, there will be a separate company hosting the entire software, right? Connectivity and everything will be managed, let's say, by, you can connect it through Wi-Fi, Bluetooth, or your data, using your data. That means connectivity part of it, the connection part of it is totally handled by a different company, right? And managed services, so all these services are managed by different companies. Basically, if the device producing company is giving the product and showing that with this product you will get this application, the services are also managed by that particular company, which would make contracts with the application developer, and the application developer would then interact with the cloud service provider if there is a issue on that part. So that is how things go. It's a little bit maybe complicated, but this is how value chains are there. So in a IoT value chain, you will find these components. All these components together produce a IoT system to the customer, which gives value. All these things add value to the IoT system. Or to put it in another way, if you are a user or a company or a person who's going to buy IoT product, the value or how much the IoT product would cost, either a system or a single device would cost, will be a collection of all these components, right? So from that, now understanding the value chain, understanding in IoT value chains, and understanding either M2M, OT, IIoT, all these same thing. Uh, we can now step into talking about looking at who are the manufacturers out there in the market, who's building what, and what is taking place, who are the companies out there who's adding value to the IoT ecosystem. So in IoT value chains, we talk first about device manufacturers. Um, we talked about the devices. So because we talked about devices, we have to talk about device manufacturers. And in build in having IoT value chain, we talked about uh, that even device manufacturers can give um, the whole package from networking to back-end development, front-end development, because we can get apps or monitoring services, so applications that can provide necessary data from the IoT, so on and so forth, as well as maintenance of the or the management of the entire IoT system itself. But we will break down components and see what companies or what are there for each sector or each link of the value chain. What are the companies which concentrate more on each link of the value chain? So in this, we have device manufacturers that would be more giving more priority to producing the IoT device itself or producing the hardware component itself. So device manufacturers are responsible for designing and producing the physical IoT device, or in Internet of Things, IoT, things producing the thing itself. These devices can include sensors, actuators, gateways, wearables, and other connected devices. Device manufacturers focus on hardware development, including components, embedded systems, and firmware. So, as we spoke before, right? Like uh, development of these each hardware component would need lot of R&D, and like these sensitive components of a IoT device, right? The bare essence will need a lot of R&D and manufacturing capabilities to produce them. So there are companies that can be doing them, and on top of that, to produce a IoT device itself, to produce the device itself, there will be companies that can assemble these things. So okay, so in here we talked about sensors, actuators, gateways, wearables, and so for example, wearables would be a part of, like, connecting all these sensors and actuators together. Other connected devices manufactured focus on, so hardware development include components and embedded systems and firmware. So which companies here you can see that provides these components, or these concentrate more on hardware? So we have Raspberry Pi over here. We know that it is a company mainly dedicated to building embedded systems, right? It gives a platform, or it gives the chips, the board, the memory, uh, the processing power itself, networking in one board, one development board. Then, in a similar fashion, we have another hardware component, which is Arduino, right? Arduino is a company which is mainly highly concentrating on, or built on, producing hardware components for IoT. This includes their development boards, right? So mainly it is for prototyping, but we can use it for manufacturing other products, IoT products as well. Mainly they have their development boards, followed up by uh, a full set of sensors, which can integrate with the embedded system to build embedded IoT devices, right? So they are a manufacturer of sensors and embedded systems. What about um, what about the complicated aspects of IoT device production? For what I'm trying to um, what I'm trying here is complicated means using lot of sensors, use of lot of actuators, use of lot of processing power. Who are the people who build IoT devices themselves? So here we have Siemens, right? They produce industrial level um, IoT devices. We have General Electric, which is also a producer of industrial level IoT devices. We have Huawei, which is more towards customer based IoT devices, right? Siemens and General Electric is more towards business to business. We have Honeywell, we have ABB. So we know that ABB are for robotic arms. Honeywell is also for electronic components, and these are mainly again business to business IoT service providers. They have their own set of IoT products, which caters from sensors. We talked about in the past lecture, in lecture number 7, we talked about how these companies, some of these companies actually, make their sensors for predictive maintenance and things like that, right? uh, we have uh, so also Amazon is one of those companies that build small IoT devices for customers. So you can see that there are different components which have been built by different companies. um, and a startup, if you are to start up a company based on IoT, right? Building the device itself, like you see on Amazon, right? There are many products on Amazon, which even there are Amazon products themselves, which are compatible with Alexa and so on and so forth, to you you know, to facilitate smart homes. Huawei has its own set to facilitate smart homes. So these, you can look at those products. You can take Raspberry Pi, you can take Arduino components to prototype your product in a startup, right? And if you want to develop it to a industrial scale, or to give a company an industrial solution, you can then use either sensors or components which are made by Siemens, General Electric, Honeywell, which would have more capacity, more sensitivity in sensors, and so on and so forth, to give a IoT product, which would be on in industrial scale, right? So I think now we have an idea on what are the products, right? If you want to some do some research by yourself, um, I would recommend, you know, going to each company and specific. Of course, these companies like ABB, Honeywell, General Electric, Siemens, these company, Huawei, they have their own line of products, which vary from different subjects. So you can type in their names and IoT, then you will be directed to their IoT specific IoT products themselves, right? But these are just examples, and keep in mind it's not limited to these companies. There are plenty of startups out there which has their own products, right? You have seen in the last lecture the examples in agriculture, or um, right, you have seen DJI drones, how they work and how they help to monitor the electricity grid, and how controls is like they have their own control systems and so on and so forth. So um, the size, so here I put these names because they are famous names, so that you will have idea on what is going on. But if there are thousands of startups out there, agriculture field, or industrial, it could be mining, it could be weather, it could be it could be even defense industry. So depending on the large number of industries and domains that we have, there are plenty of companies, plenty of startup companies which makes IoT devices. But here these names are there just as example. From device manufacturers, we can go to connectivity providers. Connectivity providers play a crucial role in enabling communication between IoT devices and the internet. They provide the necessary connectivity infrastructure, including wire or wireless network, cellular network, satellite network, and LPWAN technologies. These providers ensure reliability and secure data transmission between devices and the cloud. Yes. So Internet of Things, one part is the thing. We talked about who are the companies which makes the thing. Now it's time to talk about the company that provides access or maintains the internet, right? Internet is a network of large number of devices around the world, right? uh, Today everything is moving towards cloud technology. So when IoT and cloud meets together, that means these IoT devices have to have the ability to connect to the cloud itself. So therefore, networking is very important. Um, of course, in IoT, there are two types of networks, right? There are networks for IoT systems where IoT devices speak to each other, right? You can see the if you can see the diagram here, right? You will see Zigbee, you will see Sigfox, LoRaWAN, these Z-Wave is here. So these networks are specifically dedicated to IoT networks. So sometimes when you have some kind of a sensor which is wirelessly fixed without a power source, or the power source is a small battery, and you need it to run for maybe a couple of months or couple of years, you need uh, networking protocols which will take less energy. So Zigbee, Z-Wave, LoRaWAN, Sigfox are mainly built on that concept, right? They are mainly built to facilitate numerous devices with spending the lowest amount of energy for communication, for networking. So that is why this networking is important. So when coming into networking, again, inside the IoT system, networking could be done through uh, conventional ways like Wi-Fi, NFC, or cellular, or things like Bluetooth. But uh, depending on the requirement of the IoT product or the customer, we can use Zigbee, Z-Wave, Sigfox, LoRaWAN, things like that, which use minimum amount of energy for data transmission, um, specially made for IoT devices. One of the main reason for these things are IoT devices sometimes are ad hoc devices. When you have legacy buildings, when you have legacy machinery or things like that, the IoT devices would need to function on battery power, or if because uh, uh, the main because there will be no availability of electricity to that particular location, or it would be a remote location, things like that. So depending on the situation, right? If you take old factory, or if you take old building, if you want to provide IoT solution for that, or if you are going to give wearable devices for uh, let's say 100 people who are attending a function, and you're going to monitor their vitals and send messages and take data from them, right? And you need those devices to function for a couple of days, maybe a couple of months. So if that would be the case, and they are working through a battery, the limitations are there for the energy use. So these protocols are specifically made for tackling those kinds of situation. And end of the day, if you have a building and if you have uh, 5,000 uh, or we have a building complex and you have 5,000 fire alarms and 1,000 security cameras um, uh, and other IoT devices to monitor the temperature, the air quality, so on and so forth, to security sensors to see if the doors are open and closed. So all these things are there in a centralized system. Um, it is much more efficient to run these protocols which are dedicated to IoT systems rather than using the Wi-Fi or using NFC or using Bluetooth or cellular, which will take more energy, and there will be uh, uh, the that particular bandwidths for like cellular Wi-Fi, they can be used for uh, they can be used for much more better purposes. Because we know that Wi-Fi connections and cellular connections are used for daily communications and connecting to the users, connecting to the internet, so we cannot saturate that environment with other devices and make the internet slow. We can use those Wi-Fi routers and those things for other purposes. It will free up those things. So energy, all these points are there when building a IoT system. And companies like Zigbee provide their own networking protocols. So beyond the system, after all these IoT devices using Zigbee, there will be a point that you need to upload those data into the cloud. So beyond the system, there will be internet protocols being used. These protocols are normal standard protocols of the internet itself. Um, so if you have learned about networking, you may know what are the protocols, what are the things that are needed. When coming into hardware components, right? When building a network, number one, Cisco. We need Cisco hardware for switches, core switches, so on and so forth. We would need um, Cisco hardware. Huawei, again, uh, all the all the components, like in Sri Lanka, most of the antennas out there for cellular connection is from Huawei. If we are to use that, that would be the same. We like if we are to build a IoT network through cellular connection, we will be using Huawei components. Most probably we would be using Cisco components as well. Then if we want some networking inside the cloud itself, then we will be using Azure or Oracle or whatever the cloud we are using. We can use it for virtual networking purposes. Um, we have so Zigfox, we have Zigbee for those things. Oh, and TP-Link. TP-Link is also there as a part of networking, right? Wi-Fi routers and those hardware components are there. All these things run necessary protocols and the software component of it, right? To run the necessary protocols, manage networks. These things are mainly network related things. So not only providing these hardware, there is another component, service providing. We talked about it, to maintain these hardware components, managing services here, to manage the wires, the hardware components, to security, so on and so forth. So there is a whole industry that is dedicated to that, right? Again, Dialog, Mobitel, Airtel, Etisalat, all these things are there for that. They maintain a network as a service. So if we are to join that network, we have to pay for their service for maintaining it, and we have to join that particular network. So that is the network aspect of it. There is, of course, management and hardware of the network itself. Then point number three was so point number three, service enablers. We mostly we talked about, so we can talk about application development and backend. So first we will look at the cloud aspect of um IoT. Cloud and platform providers, platform providers offer the infrastructure, software and services needed to manage the and process the data generated by IoT devices. They provide scalable and secure cloud platforms for data storage, analytics, and application development. These platforms often include features like data management, real time analytics, device management, and integration with other enterprise systems. So you can see the one of the main points that has been highlighted is data management, data processing, right? We have talked about this also before. In IoT, because the number of devices are a lot, and things that these devices can, the number of sensors that we use is a lot. The amount of data which, or the amount of data points that it creates is also a lot. So we need large scale data management or big data management. We have to store it, we have to process it, and sometimes if you have a security system, if you have a fire alarm system, um, if you are monitoring your machinery, so on and so forth, you have to provide real time data analytics as well. So cloud service providers, here we have Microsoft Azure, we have Google Cloud, we have Oracle Cloud, IBM. There's a lot of, even Arduino has its own cloud for IoT, dedicated for IoT. So in that way, right, all these cloud service providers provide, uh, if you go to their website or if you search about their services, they have a dedicated section for IoT. They have a dedicated section for IoT. So in the Internet of Things, providing cloud technology, right, keeping the data secure, keeping managing large quantities of data, real time processing or batch processing depending on what is required. Cloud is the best place to handle these things rather than running your own servers. It would be the best place. You can host your applications which are related to the IoT systems. You can extract data from which was stored in the cloud itself, and you use the cloud services to run your application, um, where you can give in data and meaning to your dashboards, or send out alarms applications, or build your applications to give notifications, so on and so forth. So mainly this component of it, right, if you are to connect to the internet itself, means that, and to use the internet itself, you are connecting to a set of servers somewhere, somehow, right? And there are people who manage these services in large scale. It could be Microsoft, it could be Google, it could be Oracle, it could be IBM. So depending on your need, you can select their services, right? Mainly it would be for the application developers, right, to choose the respective cloud service, right? Because this has nothing to do with the hardware development or hardware manufacturers or device manufacturers. Device manufacturers is totally a hardware oriented process. They will build the hardware, they will say, okay, this hardware will produce this set of data, right? There will be a bit of edge computing or processing taking place inside the device itself to create meaningful data and give it out. But to find a place to store that data, to find application to show that data, process that data, everything, so you can use cloud facilities. As I said before, there are dedicated cloud facilities to for IoT itself, because we talked about it before, right? The market perspective seems positive. That's the way it goes. So, for cloud technology to host IoT solutions is a very normal or a sound solution. So, from that, we can go to application development, which would be here. We application development would be front end plus back end, which will be using cloud services to store data and so on and so forth. So I think by now you understand um how value chains are created and how these value chains are a part of uh, a set of links together, providing either business to business support or business to user support or customer support. So if you are to develop your own application, if you for and your IoT device, you can see that you can use cloud facilities to help you with that, right? So you can see how this value chain is being built. Next point is we talked about using cloud, right? If the cloud is not something that you get um, from outside, if you want to have your on premises servers, you can do that as well. Then we can come to application developers is IoT applications. Here we have dashboards, we have notifications or alarms, so on and so forth. So these are the or you have phone applications, you have web applications, so on and so forth, right? So UX design, DevOps, and all these things are part of application development. So here application developers create software applications that leverage IoT data and functionalities to deliver specific services or solutions. They develop custom application dashboards and user interfaces that enable end user to interact with IoT devices, monitor data, and uh, control connected systems. Application developers may also leverage APIs and SDKs provided by IoT platform providers to faster development, right? So as you can understand that, um, let's look at an example of how this takes place, how these applications and everything works, how these APIs and SDKs are used in the real world, right? So you can see that there are, if you take Alexa, right? We have seen videos, we have seen real life demonstrations. If you go or to the internet itself, you can see it in TV shows. When you give voice commands to Alexa, there will be numerous amounts of things that you can do. You can adjust your temperature in the in the room. You can turn the AC on off, heating on off, you can switch the TV on off, you can switch the lights on off, and you can do many things in a smart house. But all these products are not made by one company. The smart lights could be produced by a different company, and in the advertising they would say it is compatible with Alexa. The air conditioning company would be the same, so it would say it is compatible with Alexa. So this is where we say, okay, APIs and SDKs have been shared with uh, been shared, and these so that to build compatibility for the ecosystem, right? In IoT, one of the main points that like most main points are that there's scalability in IoT, right? When you have scalability, that means whatever the product, if the function is the same, right, and if it should have the capability to connect to the existing network. So um, in that so the existing network is hosted by Amazon or Alexa system, right? The hardware components, the IoT devices should be able to connect or integrate with the Alexa system, right? So application development takes such a path as well. uh, so develop and of course companies which have their own application developments. Again, an example that comes to my mind directly from last lecture, right? We talked about DJI, we talked about um, I think ABB sensors which are connected to motors and those things. So these companies also provide their own application for giving out alerts, for more showing data, showing the necessary data of the machines, right? Making predictions and so on and so forth. So that option, that means that that capability is also there. But if, let's say, there is a project which is going to be uh, let's say pumping fuel or petrol or petroleum from one place to another, which would be, let's say, 500 kilometers, right? And some engineering company has got the contract for this, and they are looking for hardware components. If to measure the pressure inside the pipes, so they think the your IoT device gives a good product, right? Is a good product for this project, right? But the applications are to be developed by the main company, because they are going to integrate several set of hardware devices into one system, right? SDKs and APIs should be like, by providing those information, by giving a SDK, right, it is easier to build a bridge between the hardware device and the application, so that data can flow through for the data integration can take place, and that data can flow through from hardware to the software that you develop to the main application which is being used by the customer, right? Those are for more complicated devices. But again, when you buy your security system, IoT security system, or whatever. You will have your applications with you. You will be able to see live feed from that, right? You will be able to see the data from that, so on and so forth. So that means, um, so there will be, definitely there will be human interaction between the IoT device or the hardware device of IoT, e- and the human being. So to have that interaction between the human and the machine, we need an interface that would come in the form of a application, or that would come in the form of software, right? Like basically, if you are looking at if you are looking at this lesson through your phone or through your laptop, right? If there is no software in that laptop, it would be just a hardware component. So that means in IoT, yes, we are concentrating more on how hardware to be networked and connected to the internet, but eventually there should be a software component to it, or software component to it for interaction. If there is a software component for interaction, that means there's a front end and a back end. So application development is there at the end. Again, for these application development and things like that, right? There are companies that provide these services, right? um, and you can be there will be also startups as well, right? Like, you can move a step further to the shallow end, and you can find several IoT devices. You can say that, okay, I'm going to have a startup which is going to give IoT solutions, right? Or build smart homes. If you're going to build a smart home, you can be only this, like, you can build an application to your smart home. You can buy all the hardware from other companies, right? So as you can see, you can join from any point in this value chain. As a company, as a business, you can join to any part uh, of this value chain and create value, right? Then the next one would be system integrators. System integrators bring together different. So this is what uh, I'm talking about. System integrators bring together different components and technologies to create end-to-end IoT solutions. They specialize in integrating IoT devices, connectivity, cloud platforms, and third party systems to develop com- comprehensive solutions for specific industries or use cases. System integrators ensure seamless interoperability and optimize the performance of the entire IoT ecosystem. So this is what I was talking about, right? To step into the world of IoT, you don't need to be Siemens, you don't need to be ABB, you don't need to be Huawei. You don't need to even produce a hardware device. You can basically put all those things together, develop a package, and help to maintain that package. If a company is looking to have a set of solutions through IoT, right? Let's say a logistical company wants to, uh, a logistical company in, let's say, a logistical company in Sri Lanka wants to have keep eye on their trucks or vehicles which are going around. So how to do that? If you remember the last lecture, if you have gone through the last lecture, you know that there are IoT devices that can be fixed into the vehicle which can provide all the data which needs for logistics. If that is the case, we can be a service provider and help get those hardware components, fix them, and maintain their software, maintain their hardware components, right? If there are any errors and so on, so we can give them that as a package, right? Uh, that is system integrators. Dialog is a system integrator. Mobitel is a system integrator, right? Because they don't build the switches, they don't build the core devices, they don't build the fiber optic cables, they don't build the antennas, they integrate them together to provide a network as a service. Similarly, you can provide a IoT system as a service, right? The IoT solution as a service. So integration part of it, because why this is important, this point is important for countries like Sri Lanka, is that we are still in the starting stage of the technology, right? And if we are in the starting stage of the technology, if we build, let's say if we are to build something like Arduino or Raspberry Pi, we don't have, or to build a sensor itself, we build a specific sensor. In Sri Lanka we don't have a market, then we have to go to abroad for searching for markets. But if you are a IoT service provider, right, where you say, okay, we can build and maintain IoT ecosystem, right? We can coordinate with all the hardware suppliers, we can coordinate, we can build the network, we can maintain the application and the cloud behalf of you, right? We can provide all the ecosystem. You need smart smoke detectors, we can make them, we can, and have softwares to send alerts to needed parties. We can have security systems which can process any trespassing movement. We can have a RFID tag system to monitor the logistics. We can have fingerprint sensors to see who's coming into the office and who's going out of the office. uh, all these things. We can control the temperature of the manufacturing rooms using our IoT devices. We can give that as a package, right, to build that ecosystem and maintain that ecosystem. You can start from there. You can buy the hardware, you can buy the software from outside, you can buy the cloud services from outside, combine them together, give them as a service. So building the ecosystem is a important part, right? um, so in depending on the opportunity you have, this is a good starting point. So that would be IoT as a IoT ecosystem as a service, like Mobitel or Dialog giving the network, cellular network as a service. You can give IoT ecosystem as a service. For that, so that means you are giving everything to the customer, and this everything is built on different value chains which will create sensors and create actuators and sensors. Those things will be put together and will be creating a device, and another value chain would be creating the connectivity will be creating the cloud, will be created. So depend, so putting them all together, you will be managing all these services in the ecosystem, right? These are all opportunities that are there in the value chain of IoT. As a startup, if you want to build a IoT device, that is the best solid thing in IoT, right? Because if you are stepping into IoT industry, of course you have to have a hardware component. On top of that hardware, the software component is built. The network, the back end of the software, where the cloud and everything functions, or the front end of the software. You can bring your own product to the game as well. Today we have services like Amazon, we have services which allows us to sell products overseas. So we not only have the opportunity to start at locally, we can start as a system integrator, but there is we should not shy away from building our own devices, because we have the ability to sell abroad with the technology we have today, right, in markets like Amazon. uh, so after that we have another three topics, which are data analytics, which is also as a cloud service, this comes through. Then we have service providers and users. So um, this part of the value chain, right, we are now going towards service providing part. Data analytics mostly goes towards cloud part. We will talk about them in the next lecture. For now, I think we have covered up to 2 hours, or close to 2 hours. So we will pause our lecture from here. From the next lecture, we will cover the rest of the lesson. Have a great day, everyone. See you in the next lecture.